So also, um, I will start posting the notes, the videos at least online. Everybody should have gotten that message, that the messages are there. What I'm having trouble with is all of the copiers we have here, I can't scan from. And so all my notes, I have to find a printer I can scan from so I can download them and I can send them to y'all. For right now, it's just going to be videos. All right. Last time we talked about the Cartesian coordinate system, the XY graph. I waited as long as I could. What is that dot called? It's called a point. Very good. If we had if we had 2 points, what can we do with that? We could make a line. What else? Yeah, if we have two dots, we have 2 points, we can figure out so much stuff. We can figure out the slope. What else can we do? Find the equation of the line, which I'm simply going to write EOL from now on. The distance between the points. What else? You're reading pretty well. The midpoint between the points. So here we have point 1 and point 2. What constitutes a point? What do we need to have a point? More precisely. Ordered pair. The ordered pair is that. You have the X component and the Y component. And it's always, 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 internationally, it's the same configuration. The X-axis goes first and the Y-axis goes second. You're right. This is called an ordered pair. So let's look at these 2 points. What are the locations of those 2 points? Or we can also say the coordinates of those 2 points. What are the coordinates? 1, 1, and this one? 5, 4. Yep. Now, once we have a line, what exactly is a line? We use these words, but what do they mean? It's more than that. It has a slope, but a slope is not a line. What's that? You're getting closer, but what about them? A line is an infinite number of points that are all what? Or that have the same what? That they have the same slope between each pair of points. Now, what does that mean? If we had a line is made up of an infinite number of points. Each one of these points on this line have to have they have to be connected by the same relationship. That relationship is the slope. So let's define that first. What is a slope? In words, what is a slope? Rise over run. Yes, that's partly correct. Again, that's thanks to your elementary school teachers. But this only tells me that the lines go up. Can the lines ever go down? So in reality, it's rise or sink over run. Rise means what? Means you're going up. Sink means you're going what? You're going down. And run, because remember, mathematics is a language. We read left to right. We always go from left to right. So in other words, what this means, if we looked at all these points here, this one would be point A, this one would be point B, this one would be point C and point D. Or this one's point 1, point 2, point 3, and point 4. You notice how I'm going left to right. I'm labeling them that way. So every point has to have a universally accepted manner of which you could locate them and identify them. So when we say rise, what axis does that deal with? What axis deals with up and down? Yes, so this has to do with the y-axis. And the bottom part, left and right, deals with the x-axis. More so, it has more to do, because remember, to have a slope, we need to have 2 points. To have a slope, we have to have 2 points. Here's point 1, and here's point 2. So horizontally, what's happening? This is x1, and this is x2. These subscripts, what do subscripts represent? These are called subscripts. It's a subscript. It's an index. This is an index. It tells me, is it the first one, the second one, the third one, the fourth one, whatever. So if this is the X value, what would this one be here? That would be Y1. Because this is my first point. This is point 1. Its X component is X1. So point 1 is made up of X sub 1, Y sub 1. The subscripts tell us which point those belong to. This is point 2. So what is point 2 made up of? Well, point 2 is made up of X sub 2 and Y sub 2. And that's going to become apparent in a minute. Once we start dealing with formulas, we have to know where do we plug in our values. So the rise and sink, this has to do vertically. How do I find out how far it's moved vertically? In other words, let's say this was 1 and this is 4. How far is it between 1 and 4? Yeah, between 1 and 4, it's 3 spaces different, right? How about between 2 and 19? How far is it between those two? Somebody else. Okay, if you can't answer anymore. If this is easy for you, great. I want to hear from everybody else because if you guys don't know what's going on, don't let one person answer all your questions for you. It's going to make class go faster, but you're going to fail your test. How many numbers is it between 2 and 19? Why? When they teach, so what's the method? How did you find it? Or 19 minus 2. That gives you 17, which is 19 minus 2. How'd you get 3? 4 minus 1. How about 10 and 100? Somebody else. How many? 90, because we have 100 minus 10 is 90. So if I had, in general, if I had y1 and y2, how far is it between those two? But two guys who always answer, I don't want you to answer anymore. Nope. Look how you did these other ones. Nope. I'm gonna start having people come to the board and doing questions. That's because you guys are letting 2 people or 3 people try to answer everything for you. I need to know what you guys know. And you're silent. So I'm gonna start having you guys come to the board doing problems for me. Starting next week, I'll have to do that. Everyone will have a chance to come to the board, show me what they know. How do we go from 1 to 4 to get 3? We take the second point minus the first point, right? 2 and 19 took 19 minus 2. 10 and 100. 100 minus 10. So how would this one be? It would be the second number minus the first number. The difference between two numbers is always the second number minus the first number. So this would be y2 minus y1. What is y2? What does y1 represent? Not points. What numbers? You're trying to define slope already. Have we seen y1, y2 anywhere on this page? You haven't? Yeah, right here. Here's y2, here's y1. Had you been paying attention, you'd have seen that. Here's x2, here's x1. Point 1 is made up of x1, y1. Point 2 is made up of x2, y2. So what does y2 represent? Not the second point. Because what is a point? A point is an ordered pair. Y1, y2 is not a point. You're getting around it. I know you see what it says, but you can't put it into words. Y2 is the y component of the second point. That's all that is. It's the y value of the second point. What's y1? Y1 is the y value of the first point. So again, it's the y values of the second point of the first point. On the bottom, what would the run be? What's the difference between these two? Very good. And instead of writing the word slope, we use the letter M. This is your formula for the slope. There's your slope formula. You have to understand what these are talking about. What is y2? What is y1? What is x2? What is x1? Now, in math books, what you're going to see is this. That's another way of writing it. That's another way of writing the slope equation. This little triangle, in mathematics, it's called delta. So the way you would read this would be delta y over delta x. What that means, delta represents change. The change in y or of y over the change in x. All of those mean the same thing. Around the world, it means the same thing. But this is the equation that we'll be using, which you'll plug into. But what I'm trying to get you all to use is when you take notes, first off, you don't have to write down everything because you'll have all this stuff given to you. Instead of writing y2 minus y1 over x2, you can just write delta y over delta x. That's going to save you so much time from having to write y1 minus y2 and so on and so forth. Find the slope of the line connecting 3, 5 and 7, 15. Now, whenever you see a problem, there are 5 steps you have to go through. First off, what is it asking you to find? Oh, it's asking you to slope. So do we know a formula for the slope? The formula for a slope is y2 minus y1 over x2 minus x1. So in order for us to find the slope, what do we have to have? We have to have these 4 numbers. So let's label. What is x1? X1, remember you have 2 points. So this is point 1, this is point 2. They're points. Since this is point 1, that means this is x1 and that's y1. This is point 2, so that's x sub 2 and that's y sub 2. You have to know where these numbers come from. So x1 you said was what? 3. What's x2? X2 7. Y1 and then y2. That's the hardest part. If you get that wrong, doesn't matter how good your formula is, you'll get it all wrong. You have to be very careful about that. Make sure that you know exactly xy, xy. Now we just plug and play. So y2 is 15, y1 is 5, x2 is 7, x1 is 3. We treat the top and bottom separately. 15 minus 5 is 7 minus 3. Can I simplify any further? What do they both have in common? Yeah, so 2 goes into 10 5 times. 2 goes into 4 twice. That is your slope. Don't put it into decimal. Don't put it in percent. Leave it that way. Because remember, what is a slope? How do you define slope? How do we first define slope in words? Anybody? What is a slope? Very good. It's rise over run. What this one tells us, this tells us exactly the relationship between the points. So we go to the first point. 1, 2, 3, 1, 2, 3, 4, 5. So there's our first point, 3, 5. What the slope tells me is to go to my next point, what do I have to do? From this point, what do I have to do? Well, remember we said rise over run. It's rise because it's positive 5. If it was negative 5, it'd sink. It would go down. So from this point, we go up 5. 1, 2, 3, 4, 5. Now, the bottom number is always positive. Remember, the bottom number is always positive in fractions. So what this says is from this point, go 2 to the right. That's your next point. So there's your graph. Go up 5 and over 2. So let's say that my first point is at, find me another point on that graph. Find me another point on that graph. So what's the first thing you got to do? First thing you got to do is plot the point. You need some place to start. You need a point. The only point we have is at 0, 3. So where do I go? Where's my 0, 3 on this graph? On the y-axis or x-axis? Y-axis, yes, because I go nowhere in the x, I go up 3. So I put a dot there. Now, remember, is this a proper format for a slope? No, because you cannot have negative on the bottom. So how do we fix that? Just move it to the top. Because if you have a negative outside of fraction, that negative sign belongs to the top number. Why is that? Well, because let's say we had this equation here. What's the rule for adding and subtracting fractions? What do you have to have? Common, yes, common denominator. Denominator is the bottom number. The bottom numbers have to be the same. If the bottom numbers are the same, I just write it. And then all I do now is that's how come the negative sign goes to the top number only. So 5 minus 3 is 2 over 7. That's the reason why whenever you have a negative sign, it belongs to the top number. So back to this thing. Our slope we know is 3 over negative 4, which is actually negative 3 over 4. So from here, which direction do we go and how many spaces? Down 3. So it's 1, 2, 3, and then over 4. So from here, 1, 2, 3, 4. And there's our next dot. And there's our graph. So whenever you graph lines, if you have a point and the slope, plot the point, follow the slope from that point, and you're done. Pretty easy so far? Okay. Graph this one. Graph this one. Okay, so what's my first step? Plot the point, 1, 2. So I'll go to 1 and up 2. I put a dot there. From there, what do I do? What's the slope? So what do I do from this point? Go up 2, then what? No. Over 1. Because, right, 2 is 2 over 1. So we go over 1 only. If you went up 2 and over 2, if you went up 2 and over 2, then your slope would be 1. But since it's 2, we know 2 is the same thing as 2 over 1. So far, so good? Anybody lost? All right. The next one asks, is a point on a line? So here we have, this is my equation of my line, EOL, is 2x plus 3y equals 18. That's my equation of a line. I have 2 points, -5, 7, and 3, 4. How do you prove if those points are on that line? Hmm? How do you mean? Very good. Because very good. But each point is made up of an x and y component, right? So just plug them in. So let's see the first one. So in place of x, we put -5 plus 3. In place of y, we put 7. Does that equal 18? So now, remember I said last time, treat the signs and the numbers separately. Positive times negative is what? Negative. 2 times 5, 10. Positive times positive, positive. 3 times 7, so -10 plus 21. Remember, by commutativity, we can move them around. We can move them around. We can say 21 minus 10 by commutative property of addition. What is 21 minus 10? Is 11 the same thing as 18? No. So this is not a point on that graph, on that line. Let's try B. This is the x, and that's the y. So 2 times 3 plus 3 times 4 equals 18. I just plug them in place of x and y anywhere. That's called substitution. If I have an equation and I have x and y, I just plug them in there. 2 times 3 is what? They're both positive. 3 times 4 is 6 plus 12 is 18. 18 equals 18. So 3 and 4 is on that line. So that's how you determine if a point's on that line or not. So far, so good. So if I give an equation and some points just to see if it works, plug it in there, see if it's equals. Same line. 2x plus 3y equals 18. Graph it. We're going to learn multiple methods on graphing equations. First off, what kind of equation is this? In other words, when I ask what kind of equation is this, when we draw the graph of it, what's the graph going to look like? What shape is it going to have? A what? No, it's not going to have a curve. Notice that the x and y don't have anything, no powers, no square roots, no absolute values. If they're just x and y, we call those linear equations. So this is a linear equation because x and y don't have any powers, any exponents, any square roots, anything. They're just x and y. In other words, what that means is we know that when we draw it, we're going to get a graph of a line. Now, why is that important? What do you need to draw a graph of a line? To graph a line, you need a point and you need the slope. Or you need 2 points. Either one of these two conditions will work to draw a graph of a linear equation. And we're going to use the same equation to figure this one out. Right now, let's find 2 points. The first 2 points we're going to figure out. So here's our xy. Let's say the graph looked like this. The only thing we can determine on that is these 2 points here. Where the graph crosses the x and y axis, this is called the x-intercept, and this one's called the y-intercept. So let's say this is at -3 down here, and that's at 2 up there. Everybody follow me so far? So for the y-intercept, what's the location of that point right there? What's the location of that point right there? Very good. It's at 0, 2. Very good. How about the other one? -3, 0. Everybody follow that so far? Let's look at another graph. Let's have a graph that looks like this now. So what's that point called? Which axis is that? It's the y-axis. So this is the y-intercept. What's its location? 0, comma 2. This is what is that point called? The x-intercept, because it crosses the x-axis. And what is its location? 3, comma 0. So there's a pattern here. To find the x-intercept, what do we notice about the x-intercepts? Okay, but what's the other number? 0. For the x-intercept, we cannot have a y value. So to find the x-intercept, first thing you do, set y equal to 0, and then solve for x. Because your x-intercept will always be x comma 0. To find the y-intercept, what do we notice about the y-intercepts? Where's 0? There's no in front. In the x. So the x values are 0. Because notice, on the y-axis, there are no x values. So here, for the y-intercept, set x equal to 0, and then solve for y, which is going to give us 0, comma y. Once you find those, then you can plot the 2 points and you can draw the graph. So let's look at this example we have here. 2x plus 3y equals 18. Let's find the x-intercept and the y-intercept. So how do we find the x-intercept? We have our equation, 2x plus 3y equals 18. How do we find the x-intercept? Somebody who hasn't answered yet. Set y equals 0, so we have 2x plus 3 times 0 equals 18. And then solve for x. Well, what happens 3 times 0? What does that become? 0. So that just disappears. So what we have is 2x equals 18. Yeah, so to get the x by itself, we have to divide both sides by 2. So x is equal to 9. So my x-intercept is at what location? 9, 0. Very good. That's 1 point we have in our graph. 9, 0. 9, 0. 9, 0. 9, 0. 9, 0. 9, 0. 9, 0. 9, 0. 9, 0. 9, 0. 9, 0. 9, 0. 9, 0. 9, 0. 9, 0. 9, 0. 9, 0. 9, 0. 9, 0. 9, 0. 9, 0. 9, 0. 9, 0. 9, 0. 9, 0. 9, 0. 9, 0. 9, 0. 9, 0. 9, 0. 9, 0. 9, 0. 9, 0. 9, 0. 9, 0. 9, 0. 9, 0. 9, 0. 9, 0. 9, 0. 9, 0. 9, 0. 9, 0. 9, 0. 9, 0. 9, 0. 9, 0. 9, 0. 9, 0. 9, 0. 9, 0. 9, 0. 9, 0. 9, 0. 9, 0. 9, 0. 9, 0. 9, 0. 9, 0. 9, 0. Let's do the same thing for the y-intercept now. We have 2x plus 3y equals 18. How do you find the y-intercept? Yeah, so first step, set x equal to 0, and then solve for y. So we have 2 times 0 plus 3y equals 18. 2 times 0 is 0, so it just disappears. We have 3y equals 18. Solve for y, divide by 3. Why do we divide by 3? To get y by itself. But how is 3 connected to y? How is 3 connected to y? Is there a plus sign between them? Is there a minus sign? Is there a division sign? Is there a multiplication sign? Yes. Remember, multiplication doesn't have to be there to be there. This is, how do you read this? Instead of 3y, it's 3 times y. Because it's 3 times y, we have to do the opposite to get rid of the 3. We have to divide by 3. So the 3's cancel. 18 divided by 3 is 6. So since we set x equal to 0, there's our value. There's our y-intercept. So if we were to graph these two, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. Connect the dots. And there's our graph. So what can you tell me about the graph? Oh, it's a line. No. What's the slope? What's the slope? Well, let's see. Since we want to know the slope, we have to plug in the formula, which is y2 minus y1, x2 minus x1. So here's my first point. This is point 1. This is my second point. This is point 2. This is at 0, comma 6. This one's at 9, comma 0. So the first thing I have to do is label x1, x2, y1, y2. Get in the habit of labeling your points first, instead of just throwing them into the equation. So what's x1? Yep, x is the x value. The first point is 0. x2, x value of the second point is 9. y1 is 6. And y2 is 0. Once I define them, then I can plug and play. y2 is 0 minus y1 is 6. x2 is 9 minus 0. 0 minus 6 is negative 6. 9 minus 0 is 9. Can I simplify them? Yes, they both have a what in common? 3. So how many times is 3 going to 6? 3 goes into 9. So the slope of my equation is -2 over 3. We knew the slope was negative because look at the picture. As we go left to right, where's the graph going, up or down? So the slope is negative. Slope is less than 0. It's negative. It's negative 2/3. Does this always work? Does the intercept method always work for graphing? Well, let's find out. So tell me the x and y intercepts. So the x-intercept and the y-intercept. We have the same formulas. 3x minus 5y equals -10. 3x minus 5y equals -10. So to find the x-intercept, what do I have to do? Set y equal to 0. So that disappears. So we have 3x equals -10. And then divide both sides by 3. This is the problem. We came up with a number, but how do you graph that? Where would you put that x-intercept? What kind of fraction is this? It's an improper fraction. It's improper because the bottom number is smaller than the top. So how many times is 3 going to 10? Negative. So with how many left over? 1 left over. And the bottom number always goes down here. Or another way you could have done it is this way. 3 goes into 10. 3 goes into 10 3 times. 3 times 3 is 9. So this number is there. This number is there, and this number is the denominator. And since it's negative, the answer has to be negative. So the problem we have with that, where exactly is negative 3 1/3? Where is negative 3 1/3? Is it to the left or to the right of negative 3? To the left. How far to the left? Okay, now how far? See, what I'm saying is, again, here is whenever you have fractions here, even though we're guessing it's right there, you can't use, you cannot use this method on this example. If you have fractions, unless you have accurate graph paper where everything is the same and everything is defined, you can't use that. You can't use this method in this example. But let's just say it's right there. Let's find the second one. How do you find the y-intercept? Set x equal to 0. In other words, for the y-intercept, get rid of the x. For the x-intercept, get rid of the y. So 3 times 0 disappears. So we have negative 5y equals negative 10. Again, you probably forgot since last week, but never divide by negatives. Since that's a negative, change all of the signs across the equation. Now you could divide by 5. So now we know that y equals 2. So we're guessing that our graph looks something like this. We're saying something like that because, again, we don't know if this is exactly 1/3 across. And I'll show you much better. Because once you have one y-intercept, all you need to do is find the slope. To find the slope of a linear equation, first step, solve for y. When you solve for y, you're going to get an equation that looks like this. We'll talk more about this later on in chapter 1. Whatever is in front of your x, whatever is in front of your x, whether it's just a positive or negative sign or a number with a positive and negative, that is your slope. This other number, that is your y-intercept. And we can test this out because what is our y-intercept in our last graph? 0, comma 2. Very good. Very good. I'm glad you didn't say 2 because the y-intercept is a point. It's a location. It's 0, comma 2. So 3x minus 5y equals negative 10. Solve for y. What's your first step? What do you have to get rid of? Get rid of 3x. How do you get rid of 3x? No. You would, yeah, but get rid of everything else. How is 3x connected to the y value? There's subtraction between there. So to get rid of it, I subtract 3x from both sides. So 3x minus 3x cancels out. That gives me negative 5y equals negative 3x minus 10. We're trying to get the y. So we get rid of the negative sign first. Change all of the signs across the equation. So in other words, the sign of each term changes. So it becomes positive 5y, positive 3x, positive 10. Now we divide by 5 each term separately. Divide each term by 5. So the 5's cancel there. So we have y equals 3 over 5 x plus 10 divided by 5 is 2. So what does this number represent? That's our slope. What does this number represent? Yep. And so we know we did a good job because that is our y-intercept at positive 2. 0, positive 2. So to draw the graph of this line with this equation, remember we started off with 3x minus 5y equals negative 10. And then from there, we solved for y, which gave us 3 over 5 plus 2. So now I can start off by plotting my y-intercept. My y-intercept is at 2, so I put a dot there. From that point, what's my slope tell me to do? Yeah, since it's positive, I go up 3. 1, 2, 3. And then go over 5. 1, 2, 3, 4, 5. There's my second point. So there's my graph. And yes, this would be negative 3 1/3 where it crosses the x-axis. Was what we found out last time. So if the intercept method doesn't work graphing, solve it for y and then plot the y-intercept first and follow the slope. So first step is plot B, which is the y-intercept from B, follow the slope. And that gives you your next point. So graphing equations really isn't that difficult. It just sometimes requires more work than others. Is this linear? What's that? Nope, it's not linear because x has an exponent. Because the exponent, the biggest exponent in this equation is a number 2, this is what's called a quadratic equation. Because the biggest exponent is 2, we know it's not linear. Because it's 2, we know the graph will look something like this. It's going to have that basic shape. And don't worry about it. We're not going to graph this one because in order to do it, we have to do some other stuff we haven't even started doing yet. We could try to plot some points, but if you start plotting some points in the wrong place, you're only going to be plotting one half of it. So we're not going to draw, we'll do that one later on. Within a week and a half, I want to get you to a point where you can look at an equation and tell me what the basic shape of the graph is going to be. Just by looking at the equation, you'll be able to tell me what it's going to look like and where it's going to be situated. All right, so we talked about slope. Back to our original picture. We have point 1 and point 2. How far is it between point 1 and point 2? The distance between P1 and P2. You do know the formula to solve this. What do we know? We know the x values. If I just look at horizontally, I know it's between here and here. I know vertically it's between here and here. So this is my delta x. This is my delta y. Do we know any formula that deals with something like this? What formula do we know? Which formulas do we know that deal with triangles? Not the slope formula. Well, yeah, the slope would be easy to find because it's delta y over delta x. We did that, yes. But is there another formula you know? How about if I call this A and I call this B and I call this C? Now, do you know the formula? Yes. A squared plus B squared equals C squared. What's that formula called? The Pythagorean theorem. Pythagoras was a Greek mathematician, lived about 300 BC on an island called Samos in Greek island. What he realized was you can figure out the length or the distance in this case of the long side if you're given two shorter sides. And they have to create a 90-degree angle, a right angle. So whenever you see a box in a corner like that, that tells you, even if I give you a picture that looks like this, if I made this box down there, this is 90 degrees, no matter what the picture looks like. It defines that this is a 90-degree angle. This is how he figured it out, actually. He took a square box, 3 by 3. Then he put they put 4 boxes side by side. They put them at a 90-degree angle. What he determined was he can determine how long of a distance is it from those 2 points. So let's look at this. So we'll call this side A. It's 1, 2, 3 units big. This side is B. It's 1, 2, 3, 4 units big. And this side is C. It's how big? 1, 2, 3, 4, 5. Because these are squared, we said if I took A and squared it, he got 9. Then if you took B and squared it, he got 16 squares. And if he added those two together, which is the same thing that C was equal to. Remember, he did this without paper and pencil. He did this on sand. He had to go back into town and put it on papyrus. But that's how the Pythagorean theorem came about. It's called for perfect squares. The sum of the legs of a triangle equals the square of the hypotenuse. So this is the hypotenuse. And these are the legs of the triangle because they hold up the hypotenuse. So now how does that relate to distance? If I give you two dots, the distance between them, I could make out a right triangle out of them. Well, what's the distance between here and here? And remember what the formula is for that? Between x1 and x2, what's the distance between there? Very good. X2 minus x1. Same thing with the y's between here and here. This is y1, this is y2. That that difference is, and we'll call this C. So that's what A equals. This is what B equals. So A squared plus B squared equals C squared, which is also the distance. So A squared is x2 minus x1 squared plus y2 minus y1 squared equals the distance squared. But I haven't solved for the distance yet. I have distance squared. How do I get distance by itself? How do I get rid of the 2 up here? How do I get rid of this 2? What's this 2 here called? An exponent, but what's it called if it's a 2? How would you read this? It's d squared. So how do you get rid of the squared? Shh. I want to see. I know you're gnawing at the bit, but again, I need to know what everybody else knows. I need to pull it out of them. It does them no good. I have to get rid of the square, I take the square root of it. So d squared, if I take the square root of it, it equals d. So if I add, in other words, I have to take it to both sides. Whatever I do to one side, I gotta do to the other side. So the square root of d squared is d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. There is your distance formula. That gives us the distance between any 2 points. Now, everybody see this. Let me show you how this works. Here's an example. What's the square root of 4? 2. Why? Because what is 4 made up of? Just 2? 2 times 2. Well, 2 times 2 is the same thing as 2 squared. So since 4 equals 2, and all this is, that means this has to equal 2 also. So that's the rule. The square root and the square cancel each other out. Or I could use the square root of 9. 9 is made up of what? 3 times 3, which is the same thing as 3 squared. The square root and the square cancel out, which leaves us with 3. That's how it works. So back to our original picture. From 1, 1 to 5, 4. How far is it between there? So we're at 1, 1, and this is at 5, 4. What is the distance? So the first thing we have to do is label our points. X1, X2, Y1, Y2. So this is point 1 and this is point 2. So X1 is 1. Y1 is 1. X2 is 5. Y2 is 4. We have our formula. X2 minus X1 squared plus Y2 minus Y1 squared. Plug them in there. X2 is 5 minus X1. Y2 is 4 minus 1. 5 minus 1 is 4 squared. 4 minus 1 is 3 squared. You notice we're always following the order of operations. Think of the order of operations. Reading left to right, we have a special operation, so we have to do inside there. Reading left to right, there's a parenthesis. We have to do inside there. We have to do inside there. Now what do? We have to square them. 4 squared is 4 times 4, which is 16. 3 squared is 3 times 3, which is 9. 16 plus 9 is 25. And the square root of 25 is 5. There's my distance between the 2 points. We're using the same equations. Have we seen these before? X2 minus X1, Y2? Where have we seen those before? Yeah, it was the slope equation. Slope equation is Y2 minus Y1 over X2 minus X1. So we're using the same formula, it's just in a different format now. Example 6. Go ahead, you don't have to tell me. This is college. -2, 2, 3, -6. Find me the distance between those 2 points. Find me the distance. But yes, we'll do that. So first off, you have to label your points. Have you done that yet? Have you labeled X1, X2, Y1, Y2? If you don't do that, start doing that. It's going to save you so much time and hassle. So what is X sub 1? It's the X value of the first point. So it's -2. What's X sub 2? What's Y sub 1? It's the Y value of the first point, and the Y value of the second point is -6. Again, the next thing you do is write your formula down. And plug and play. So X sub 2 is 3, minus X sub 1 is -2 squared, plus Y sub 2 is -6, minus Y sub 1 is 2 squared. Order of operations. In the first parenthesis, we have a negative times a negative. What does that become? It becomes a positive. And there's nothing happening in the second one just yet. So that's the first thing I take care of. Now I do inside the parentheses. 3 plus 2 is 5. -6 minus 2 is -8 squared. And we'll go over that rule next. Five squared is 25. -8 squared is 64. 8 times 8 is 64. 64 plus 25 is 89. 89 is a prime number. What you would do next is see if you can break down 89 to multiple parts. And nothing multiplies in there that equals that. So it's just square root of 89. The problem a lot of students have is adding, subtracting like signs. That's why multiplication division is easy. And we'll go over those. So let's look at adding and subtracting signed numbers. Let's look at adding first. If the signs are the same, then take the common sign and add the numbers. If the signs are the same, take the common sign and add the numbers. Here's what it means. We know 2 plus 3 is equal to, they're both positive, so the answer is what? Positive or negative? 2 plus 3 is 5. Negative 3 minus 4. What are their signs? They're both negative, so the answer is negative. 3 plus 4 is 7. If the signs are the same, take the common sign and add the two numbers. If the signs are different, take the sign of the larger number and subtract the smaller number from the larger number. So if the signs are different, take the sign of the larger number and subtract them. For example, 9 minus 3. Is the answer going to be positive or negative? Positive. So it's positive. 9 minus 3 is 6. Negative 2 plus 7. Is the answer going to be positive or negative? So it's going to be positive. 7 minus 2 is 5. 3 minus 8. Is the answer going to be positive or negative? Yeah, because 8's bigger than 3. It's negative. 8 minus 3 is 5. Negative 9 plus 2. Is the answer going to be positive or negative? Negative, because 9's bigger than 2. It's negative. 9 minus 2 is 7. You don't need calculators. Start using your brain for something other than TikTok or Instagram or crap like that. Start using your brain for something constructive. So that's adding and subtracting. Multiplying and dividing is even easier. Multiplying and dividing. Count the number of negative signs. And if it's even, the answer is positive. Else it's negative. Is the answer going to be positive or negative? How many negatives are there? Is that odd or even? Three is even? Three is odd. So the answer is, since it's odd, so if it's an even number, the answer is positive. If it's an odd number, the answer is going to be negative. Why is that the case? Because if I had negative 2 times negative 2, negative times negative is it's a positive. So anytime you have two of a kind, they cancel out. So we know the negative signs are going to be negative. So now we don't have to worry about signs anymore. Just multiply the numbers. 2 times 5 is 10. 2 times 5 is 10. 3 times 1 is 3. So 10 times 10 times 3 is, it's going to be negative 300. Treat the signs and the numbers separately. You don't need calculators. Same thing with division. Is the answer going to be positive or negative? Why? Why? How many negative signs are there? One, two, three, four. Is four even or odd? So it's going to be a positive answer. I don't have to worry about the signs anymore. So the twos can cancel. 2 goes in, 5 goes in there twice. 2 times 3 is 6. So the answer is positive 4. That's how simple it really is. So treat the signs and the numbers separately. Find me the distance between these 2 points. All right. First step is what? Label the X's and Y's. Very good. X1 is X2, negative 1 also. Y1 and Y2 is 2. Once we have those, plug them into your formula. So X2 is negative 1 minus negative 1 plus 2 minus -3 squared. So we have -1, a negative and a negative becomes a positive. 1. Negative and a negative becomes a positive. -1 plus 1 is 0. So that's gone. If 2 plus 3 is 5. Five squared is 25. Square root of 25 is 5. We could also done that here since they cancel. So the distance between those 2 points is 5 units away from each other. Any questions? Okay, let's look at example 7, which is deal with circles. Point -25 is on the circle with 3, -1 as its center. Find the diameter and radius of the circle. I took a little bit of liberty on this question because it has a lot of stuff we could do to it. So what is it asking you to find? So what are diameter and radius? What's the diameter of a circle? What's that? Nope. That's circumference. That's the outer edge of a circle. If you have a circle, it has a center, like a bicycle wheel. From the center hub of that wheel to the wheel itself, the spoke is the radius. That's how far the wheel is from the center of the circle. The diameter is from one side of the circle to the other side, going through the center. So is there a formula we can use for both of these? Well, how is diameter and radius related? Remember, radius is from the center to the circle. Diameter is from circle to center to circle. Just by looking at it, isn't diameter twice the radius? Yeah, because if this is only halfway, diameter is all the way across. It's twice as far. So what we know from here is we have a circle. We have a dot on that circle, which is at -2, 5. The center of the circle is at 3, -1. Have we learned anything so far that we can use for this? What? The distance, yes. The distance from this point to the center. So we can use a distance formula with those 2 points. And that'll give us the what? The radius. How do we find the diameter? Double it. Yes. So let's find the distance between these 2 points. Of course, first thing you have to do is label your points. So what's x1? -2. What's x2? 3. What's y1? 5. Y2 is -1. Because if you get those wrong, there's no way you can get the answer correct. That's why you have to be very careful with it. So the distance, which is now the distance of the radius, which is x2 minus x1 squared plus y2 minus y1 squared. And plug them in there. X2 is what? 3. Minus x1 is -2. Y2 is -1 minus y1 is 5. So we have negative and negative becomes a positive. So we have 3 plus 2 squared, -1 minus 5 squared. Because the rest of this stuff now, we should be able to do it already. There's not much different going on now. 3 plus 2 is 5. -1 plus negative, or -1 minus 5. They're both negative. Add the numbers, -6. Very good. Five squared is -6 squared. What's 6 squared? 25 plus 36. So the radius is 61. So the diameter is what? Yeah, so it's 2 times r, which is 2 times square root of 61. There's your answer. So that's diameter and distance. The next thing you guys want to talk about, midpoints. What's a midpoint? If you had to define it, what would be a midpoint? Yeah, a point halfway between 2 other points. So in our example, we have 1, 1, 4, 5, 2, 3, 4. We have the line. I want to know what is the location of the point midpoint of that. Now, in real world, what would be an example of the use for this? Let's say you borrowed something from your neighbor or from a friend and they want it back. So you say, okay, let's meet halfway. Because you don't want to go too far because you have to pay more gas. So in fact, what's halfway between your house and my house? That's one example. Or rescue ships. What's because if I only have enough gas to go halfway, I have to be able to come back. So how far can I go? So how do you think we find the midpoint? Remember, we have the x values and then we have the y values. The midpoint is what's the midpoint between 1 and 5? What's halfway between 1 and 5? How'd you get that? It is 3, but how'd you get it? Think of if these were your grades. You made a 1 and a 5. Okay, they're not grades then. They're bonus points. What's your average if those are your bonus points? Anybody know how to find their grades? How do you find your grade average? If only you took 2 tests, how do you find your average? You divide by 2. Same thing here. The average is the midpoint. So we would take these two numbers, 1 plus 5, and divide by 2. So at 3, that's the x component. Same thing with the y values. 1 plus 4 divided by 2. 5 divided by 2 is 2.5, which is halfway between there. So that's exactly what the midpoint is. It's the horizontal average and the vertical average of your 2 points. Here we use the capital letter M. Remember, it's a point. So we have to have an x component and we have to have a y component. So we add our numbers, x1 plus x2 divided by 2. Y1 plus y2 divided by 2. And that's our formula. So find me the midpoint between these two numbers. So the midpoint of these two numbers, this is x1, this is x2. So I add those two together. So -4 plus 2 divided by 2. Y1 plus y2. So it's -2 plus 5 divided by 2. What is -4 plus 2? Yeah, since 4 is bigger than 2, it's negative. 4 minus 2 is 2. Negative 2 plus 5. Is the answer going to be positive or negative? Positive, since 5 is bigger than 2. 5 minus 2 is 3 over 2. So the midpoint, negative 2 over 2 is negative 1, 3 halves. So that's your midpoint. At negative 1, 3 halves. 3 halves is 1 and 1/2. Any questions about that? Isn't it just plug and play? That's all there is to it. It's plug and play. You just have to know how to do the operations. After so many years of using a calculator, try to do it first by hand and then check it with a calculator. You have a circle. You have 2 points on the circle, 2, negative 3, and 6, comma 4. They're on opposite sides of the circle. Where's the center? What's the location of the center of that circle? So what formula are you going to use? Remember, these are opposite sides of the circle from each other. So the center would be where on that of those 2 points? The center would be midpoint between those 2 points. Well, if I drew a line from one side of the circle to the other side of the circle, I would have to go through the center, which is halfway across it. So I'm looking for the midpoint. X1 plus X2 over 2, Y1 plus Y2 over 2. So this is X1, Y1, X2, Y2. So X1 is 2 plus X2 is 6 over 2. Y1 is negative 3. Y2 is 4 over 2. What's funny is now when I was asking the questions earlier, nobody was writing. Now that I'm working it out, everybody's writing like their lives depend on it. You should be asking questions. If you're lost, if you don't understand what I'm talking about, you should be asking questions. Not just Xeroxing, bobbleheading and Xeroxing. Two plus 6 is 8. 4 minus 3 is 1. So the midpoint, the center of the circle is at 4, 1/2. This is the center of the circle. Now, this last part is I think it's very interesting. Circles. Again, I don't want you guys to copy bobblehead and just Xerox. If you're lost, talk to your neighbor. Ask them how they got what they did. Don't just wait till me to do it, for me to do it. What is a circle? How would you define a circle? You use the words, you have to be able to define them. It's what? Just the radius? Wouldn't be much of a circle. Keep on going. Yes. Radius is part of it. What else does it have to have? Yeah, but yes, circles do. Okay, now how are you going to relate all those? What else does it have to have? The what? The distance around, that's the circumference. You never mentioned the center of a circle. That's the most important part, actually. Think of a wheel. What do you have to have for a wheel to work? You have to have that hub in the middle, which is the center of the wheel. Without it, it's not going to work. Because you can't have a radius because radius has to stem from somewhere. Has to start someplace. A circle is an infinite number of points that are all equidistant from a central point. A circle has to have three parts. It has to have a center. It has to have a radius. And it has to have points on the circle. That's what this definition just defines. Equidistant. What does that mean? Yeah, they're all the same distance. Equidistant means they're all the same distance. From a central point, which is a center. So if you think about it, we have a point. This is our center. It's equidistant. This is equidistant to that one. It's the same distance away. It's the same distance away. The more dots I create that are all the same distance away from this point, that's supposed to be a little shorter. Eventually, it's going to form a circle. But now we need to have an equation. Each one of these lines I just created create a right triangle. Every one of these I just created create a right triangle. Because remember, The radius is the distance from a center to the point. That's the hypotenuse. So the more dots I have, eventually all of these dots are going to form a circle. The circle is created by all these triangles. What formula do we have for triangles? We just talked about it about 10 minutes ago. What formula do we have? A squared plus B squared equals C squared. Well, this is the C squared is the distance from the center to the point. So that's what do you call the distance from the center to the circle? Radius. So now, instead of a distance, it's now called the radius. A squared, so we have x2 minus x1 squared, y2 minus y1 squared. That hasn't changed. But what has changed is each one of these lines have one point in common. The center point is our x1, y1. That's our center of our circle. It never moves. So instead of writing x1, y1, for the center, we now use h and k to help us distinguish between those. Instead of writing x1, y1, we put hk, where h is my x value, k is my y value. So I have the radius squared equals x2 minus h squared plus y2 minus k squared. So instead of x1, y1, I put hk in its place. Since I don't have any x1s, I don't need x2s. It's the only x I'll be using. So I have x minus h squared plus y minus k squared. This is the formula for a circle. That's your formula, your equation for a circle. Let's see how easy it is to create equations. Example 10. Find the equation of a circle with radius 3 and the center at 3, -7. Remember, it's asking for equation of a circle, EOC. This tells you what formula you have to use. The formula you have to use is this one. So that tells you what you have. Now, what do we put in there? What does it define for us? What about 3? Where does it go? Where do you think it would go in this equation? Where? Of course. R stands for what? Radius. So the 3 goes in place of R. Well, what's H? H is the X value of the center. The center is there. So it's X minus 3 plus Y minus -7 squared. We can fix that. So we have 3 squared is 9, X minus 3 squared plus Y plus 7 squared. There's my equation of a circle. Just plug and play. Radius stands for R. Rocket science. H and K are the X and Y values of the center. Nope, that's just the equation of a line, of a circle. It tells us everything we need. You could have left it at 3 squared, which would have been more descriptive because R under the squared, this is the radius I have. If there's no square, if I gave you this, if I gave you that, I want you to tell me the radius and the center of the circle. What's that? It would be what? Very good. The radius would be 4. Well, because remember, since there's the formula we're dealing with is R squared X minus H squared Y minus K squared. Since there's no squared there, we know that R squared equals 16, so we have to square root it. R equals 4. Very good. If there's no squared there, then we have to square root it. So what's my center? Just the opposite. It's always opposite of what's inside the parentheses. Think about it. Remember, H was 3. When we plugged it in the formula, it became -3. It was -7, it became +7. So whatever you have inside the parentheses, when you take them out, it's always the opposite sign. How about what's my radius and what's my center of that one? What? Same logic. What do we do here? Is there a squared on there? So what do we do? Since there's no squared there, we know that R squared is equal to 5. R is equal to the square root of 5. That's what we did last time. It was 16, so you square root it, got 4. So what's my center? It's always opposite. Yes, since there's nothing here, it's 0. Very good. What's my radius and what's my center? What's my center? Let's start with some easy. Please know if I have it correctly. It's HK, opposite signs. What's my radius? Because it's squared. Remember, what's the formula for equation of a circle? Equation of a circle is r squared x minus h squared y minus k squared. Since it's squared, this is my radius. If it's squared, it is what it is. If it's not squared, then I got to square root it. This r squared equals 27 squared, right? So those are both squared, so r is 27. Now, last thing to do is graphing. Graph this one. In order to graph it, you have to find the information we needed. We have to find the radius and you have to find the center. So what's the radius? Let's try again. Yeah, is there a square term? No, so we have to square root it. So the square root of 9 is 3. What's my center? Negative 2 comma 1. What? It's always opposite. The reason being because what we did originally, every time we started, it's always the centers in the middle, in the origin. So what would it take? What would we have to do to make that equal 0 again? That's why you flip it. It's always opposite. So now we have the radius and the center. Plot the points, plot the center. Plot C. Now, from C, follow R. So my center is at negative 2, 1, and my radius is 3. So I go up 3, put a dot. I go to the left 3, put a dot. I go to the right 3, 1, 2, 3, put a dot. I go down 3, 1, 2, 3, and put a dot. Connect the dots. And there's your circle. Once you find the center, you find the 4 points and then connect them. That's how you draw a circle. But yeah, or if you want to, you can get a ruler. But again, you're using a computer, and those once you find those, you have the radius, which you would normally do if back in the old days, get a ruler or get a pin, get a string, put it on there, and then rotate it around there, and there's your graph. End of section 1. Chapter 1, section 1. It covered all that information. So, fortunately for you guys, it's a Wednesday today, so you have the whole weekend to do this stuff. Hopefully, now you can do your homework. Made a lot more sense, I hope. And the reason I wanted to finish this is because